Hello there, I'm Mr. Saem Tarek. Today we'll be solving one of the A-level past paper. Okay, and here we plan to solve is this is May June 2022. Okay, so we'll be solving this one today. Open the document evidence. So I have the document evidence file over here. All right, you're supposed to type in your details over here, the center number, your candidate number, and all that, and we'll copy paste all the different parts over here. Okay, so make sure your name, center number, candidate number will appear on every page of this document. This document must contain your answers to each question. Save this evidence document in your work area. Evidence followed by center number, candidate number. A class declaration can be used to declare a record. If the programming language used does not support arrays, a list can be used instead, right? A source file is used to answer question 3, the file called cardvalues.txt. Point number 1, a program needs to use a stack data structure. Okay, the stack can store up till 10 integer elements. A 1D array stack data is used to store the stack globally. The global variable stack pointer points to the next available space in the stack and is initialized to 0. Okay, so obviously the use of stacks, arrays, binary search, linear search, all this is very important for P4. So obviously if you have an idea, if you don't have an idea, you can refer to one of my video where I've explained stacks thoroughly. So the first part basically says is that you write a program code to declare the array and the pointer. So we have to declare the array and we have to declare pointer. Okay, and we have to, as global data structures, initialize the pointer 0. So there are certain things that we have to be careful about. Okay, you can note them down. And we have to initialize the pointer to 0. We have to declare them global data structures and array and pointer. So let's start doing it. This is the first part. So file, new. Let's rename this. This is June 2022 password, right? Paper 42. Okay, right? And we need is 1A. So 1, right? So again, you have the question with you, you know the idea. So 1D array, stack data, and stack pointer. Okay, fine. So what we need to do is we will basically do is we will create is a global stack data. Okay. Globally, we'll declare is stack pointer, right? And our stack data will be equal to, obviously in the square brackets, and needs to be in comma separate values. We'll have obviously over 10, 4, 5, 6, 7, 8, 9, 10, right? So it's 1, 2, 3, 4, 5, 6, right? So, and then, okay, you need to always define the data types. This is required in Python when you're doing for P4. Okay, so this is an integer, and at the same time we will be defining our data as integer. This is compulsion. You have to do it while you're using Python. And stack pointer has to be initialized to 0. So this is the very first part. I'll just copy this and I will place this over here. Right. Okay. Okay. Let's go to the next part. Save. Done this. Okay. Write a procedure to output all 10 elements in the stack and the value of stack pointer. Okay. So we have to write a procedure for this. Okay. So what we'll do is we'll basically so I'll just do them separately, frankly speaking. 20, 22, P42. This is 1B. So it's 1B. Right. So here what we have to do is, let me just read once again. Okay, okay, we just have to write a procedure for the 10 elements, right? And stack pointer the name. So what we'll do here is we are going to define a function, and the function is going to print the array, okay? And obviously, same way we did before, we'll define globally the stack data, and we'll globally define is the stack pointer. And here we are going to print it, the stack pointer. Obviously, we'll print the stack pointer. Let's use for X, let's say in range. So it's from 0 till 10, right? That's how we use the for loop. And finally, what we can do is we can simply print the stack data, right? And X. So obviously what will happen in this particular case is we will run this loop iteration, and X will every time increment from 0 till 10, and will keep on printing this. So that's the way you will be doing this particular part. You have to take care of the indentation. That's really something very, very important. Right, that's the second part. Okay. The next part, C. The function push takes an integer parameter and returns false if the stack is full. Okay, if the stack is not full, it pulls the parameter value on the stack, updates the relevant pointer, and returns true. Write the program code for the function push. Okay, right. So we have push function. If it's false, it returns false. It's like it's full. Okay, and this pointer and returns true. Okay, right. Just have to think a bit about it before you start. Okay, so here we go. This is 1C. Okay, so I will be defining a function by the name of push. And this would do is data to push, right? So again, global, we have to do that again, obviously. Data global stack pointer if stack pointer double equals to 10, okay, because we're comparing. Double equal to is for comparison. Return false. Okay, else update the pointer. If the parameter, okay, updates the relevant pointer, returns true. Okay. So what we could do is we could now say is that stack data is equals to push, right? And then we could have is stack pointer is equals to, and we obviously have to run an increment over here. Okay, but hold on. I also have to write the stack pointer over here. Okay, I'll just explain this what I'm doing, and then obviously we can simply return is true. Right, so this is what we're doing over here. So we made a function, we globally declared the stack data and stack pointer, and we have a condition over here because over here it said that, okay, the takes an integer parameter and returns false if the stack is full. Obviously, if it's still 10, then it turns false. Else, stack data, we write the stack pointer as an element number within the stack data and is equal to data to push. Okay. So stack pointer is equal to stack pointer. Every time this will keep on increasing one by one. And once and this is equal. Okay, so this is the way it keeps on going on. Okay, so here we go. This is the third part, right? Then we have 1D. 1D basically, let's see what 1D says. So edit the main program to test the push function. The main program needs to allow the user to enter 11 numbers. Okay, and attempt to add these to the stack. Output an appropriate message when a number is added to the stack. Output an appropriate message when a number is not added to the stack if it's full. Output the contents of the stack after attempting to add all 11 numbers. Okay, let me just give me a second. Let me note down some key points. Then I will solve this with you. Okay. Okay. So I'll just note it down, main things. So this is part D, D1. So here we go. We have D1, right? So okay. So what we'll do here is, I will have the stack pointer assigned to 0, obviously, and my stack data is equals to, so gain those 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we have to run a loop over here for this, for again the same thing for x in range, okay, from 0 to, you tell me, you should be doing with me. So in this particular case, enter 11 numbers, so it has to go to 11, yes or no, right? We will have over here is okay, so 1 second. You can have is a number x is equals to, we could simply use over here is input and enter a number. Okay. Right. It's always advisable, obviously, that I convert this into an integer. Okay. So that there is no problem. Consider it as a number. So if now over here we made is second. Okay. Okay. If push if this is equals to true, if it's true, then we could simply say is print it's stored, else print the stack is full, right? So this is what we have, and obviously eventually we have to print the array. Okay. Right. Okay. Right. So now this is we all together now will be added to the main function, because added the main program to test the push function. Okay. So we just made the push function, as you can see over here, right? So this is the further part of it. Okay. Later on we just have to combine it. Okay. I'll just do that with you. Okay. Okay, so we will just make this part was okay done, and now we have to actually did I copy paste that? I'm sorry. So 1D1. So that was D1. Right. Then what we have to do is test your program for part D1 with the following 11 inputs. Now, obviously, at the main program, whenever you have test, you obviously have to integrate all the parts together. So just give me a second. I'll just do that with you. So we'll make as a new file. So new file, we'll make that as June 2022 P42 D2 is D2, right? So what we'll do is obviously first we will arrange it, main function. Okay. And after defining the push function, we are going to add this stack. Okay. Can add the stack over here, right? Right, and so the stack will be defined full, but we need to print the array. I have not defined the print array. Where was the print array? No, yeah, here is the print array. So the print will appear here, obviously. Okay, and then we can later on print this. Okay, so we can just check this out. Is it working or not? Okay, just give me a second. I'll just run this and well, it's text. Just give me 1 second. Just try to find out where the problem is. Okay. Oh, we had to put this, sorry. So I'll run this. Okay. So we have to enter the following. So our enter is 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Right? Okay. Stack is full. Right. Excellent. Good. So, so we have to give the evidence of this as well. Right? So we can just take, what do you have to do? Test a program, take a screenshot to show the output. So either way, we can show all of these, okay? And evidence, all this should go. Right? So we'll place this. '18 onwards. Right. So this is what my evidence is. Okay. The function pop returns -1 if the stack is empty. If the stack is not empty, it returns and eliminates it at the top of the stack and updates the relevant pointer. Okay, let me just note down some point over here. Okay. So you have to make pop. It does -1 if the stack is empty. If the stack is not empty, the top of the stack. Okay. This is 1E. Okay. Okay. So in 1E, what we're supposed to do over here is, right, we have to define function pop. Okay. So let's get again global stack data, global stack pointer. If stack pointer is equals to 0, okay. If it's empty, we can simply return -1. Else, return data will be is equals to stack data, and obviously inside stack data, we'll have is the stack pointer, right? And again, obviously, we'll do -1 decrement as the question says, and the stack pointer is equals to, obviously, what we did previously. We just are going to, in this particular case, we are just going to decrement it. We increment it, now we decrement. And obviously what we do is we'll return the return data, right? So this is what we are supposed to do. Okay, so done with this part. Okay, place it in 1E. So obviously I'll just copy this and I'm going to place it in 1E part. Right, next what we have is, after the code you written main program, add the code to remove 2 elements from the stack using pop, output the data, test your program. Because we have to put this in the program as well. Okay, so it's part 1D2. Okay, just 1 second. So let me just see. I just copied it. Where do we have to put it? So we have the push, and then we have else done. Def. Right. Turn true. So obviously what we can do is we can just place it here. Okay. Print data, pointer 0, then it goes like this and print. We can just check this out. So if I run this, hopefully it should work. Invalid. I think it's the same problem that I did last time. So I'll just enter here is 18, 19, 21, right? Stack is full, error comes in, okay? And this is how it works, okay? And we're just going to copy this and place in the evidence document as well, right? Remove the 2 elements from the stack using pop, output the contents of the stack, right? One, two, three, four, five, six, seven, 8, 9, 10. Yes, and that's the 11th one. So it did yes,